Hello students, welcome to my YouTube channel AM Teachers Tech. So today's is your lecture 6 on subject digital signal processing, that is your core subject of your 5th sem electronics and communication. So last class we have seen DFT as linear transformation, that is nothing but matrix method. So on that we are going to solve the problems DFT and IDFT using linear transformation or matrix method. So either you can call it as a matrix method or linear transformation. So under that, the first problem is compute DFT. See here they have asked here compute DFT, or just they can tell you find x of k. Okay, so if they just tell find x of k or compute DFT, so both are same here. So what is the question here? Compute DFT on the sequence. So this is the sequence given using linear transformation, that is matrix method. So we'll start solving here. So x of n is given as 0, 1, 2, 3. That means n is equal to 4. So 4 point DFT. That is, in my last video I have shown you how to do this matrix representation. So there we have seen that x of n is equal to omega n x of n. So what is this? This is nothing but x of k, or I can even write off this. In some books they are using like this. So x of k is equal to omega, that is to del n kn into x of n, like this also they are using. Okay, so this is also one way to represent the matrix, that is we are putting the DFT equation in the matrix form. Okay, so in the last video we have seen this. So x of n, so how do we write? So n is equal to 4. So if I represent this one in the matrix form, so this is your x of 0, x of 1, x of 2, x of 3. Now this one Twiddle factor, see how I have got 0 to 3 means n is equal to how much here? N is greater than or equal to 0 or less than or equal to n minus 1. So it is, what is the range here? N is greater than or equal to 0, less than or equal to 3. So that is, the range is from 0 to 3. Okay, so 0, 0, 1, 2, 3, here also 0, 1, 2, 3. So as we know, the Twiddle factor is of matrix, Twiddle factor matrix here it is 4 cross 4. So what I have done here, this side also I have written 0, 1, 2, 3, because the range of n, small n, we know that it is 0 to 3. Now only I have shown you here. So this one 0 to n minus 3, or even you can write it 0, 1, 2, 3. Okay. So how do I write this Twiddle factor? Means 0 into 0, see omega, that is to del n. Actually I should write here n. Now I know that the value of n is how much here? The value of n is 4. Instead of n, I'm going to write it here 4. So 0 into 0, so this becomes 0. Okay. Next, Twiddle of 4, or even I can call it as omega 4. This is 0 into 1, so this becomes 0. Again, omega 4 of 0 into 2, so this becomes 0. Next again omega 4 of 0 into 3, so this becomes 0. Okay, so the next value, this one is what? Omega 1 into 0, it is 0. Again omega 4 of 1 into 1, it is 1. Omega 4 of 1 into 2, it is 2. Omega 4 of 1 into 3, it is 3. Again omega 4 of 2 into 0, it is 0. Omega 4 of 2 into 1, it is 2. Omega 4 of 2 into 2, it is 4. Omega 4 of 2 into 3, it is 6. Omega 4 of 0, it is 0. Omega 4 of 3 into 1, it is 3. Omega 4 of 3 into 2, it is 6. Omega 4 of 3 into 3, it is 9. Omega 4 of 0. Omega 4 of 1. Omega 4 of 0 is 1. Omega 4 of 1 is minus j. omega 4 of 2 is minus 1. See, real is 1 plus 1, so this will be minus 1. Okay, so omega 4 of 3 is j. Okay, so as it is j, so this becomes minus j. So this is plus j. If this is a plus j, this is a plus j, so this is minus j. If this is plus 1, so this is minus 1. See, all these calculations I've shown you in my video 3, that is module 1 lecture 3. Okay, I'll put a link in the description box. You can just go through it. Okay, as we know that it is a periodic in nature, so it's going to repeat itself. So this is again, so this will be again omega 4 of 4. Okay, so this will be equal to omega 4 of 5. This will be equal to omega 4 of 6, and this will be equal to omega 4 of 7. Okay, so this is 8, so this one is 8, and this one will be equal to omega 4 of 9. Okay, now these values I'm going to substitute in this matrix. Okay, before that, these values x of n, so this matrix will be n cross of 1. So this is x of 0, x of 1, so this is x of 2, and x of 3. Now we will substitute this value. So what is omega 4 of 0? It is 1. So 1. Again omega 4 of 0, it is 1, 1 and 1. So here also it is omega 4 of 0 is 1, 1 and 1. What is omega 4 of 1? It is minus j. Omega 4 of 2, it is minus 1. Omega 4 of 3, omega 4 of 3 is here. So omega 4 of 3 is j. So here it will be j. Okay, so next is what omega, if you want I'll write down here. Omega 4 of 0, omega 4 of 1, omega 4 of 2 and omega 4 of 3. So this is equal to 1, this is equal to minus j, this is equal to minus 1, and this is equal to j. So these values I'm going to substitute here. So next is what? Omega 4 of 2. So omega 4 of 2 is how much? It is minus 1. Then omega 4 of 4. Omega 4 of 4 is how much it is? This one is 1. Omega 4 of 6 is again minus 1. Okay, so omega 4 of 3 is, it's here. Omega 4 of 3, how much it is? It is j. Okay, omega 4 of 6, it's here. Omega 4 of 6, it is minus 1. Omega 4 of 9. Omega 4 of 9 is this one. If you want, I'll write down here. Omega 4 of 5. Omega 4 of 6. Omega 4 of 7. And this one is omega 4 of 8. And this one is omega 4 of 9. Omega 4 of 9 is minus j. Now what is x of 0? So this is your x of 0. This is x of 1. This is x of 2. And this one is what? X of 3. So this value I'm going to substitute in this matrix. So what are the values here? The values are 0, 1, 2 and 3. So we have to multiply this row into column. Okay, so 1 into 0, it is 0, plus 1 into 1, it is 1, plus 1 into 2, 2, plus 1 into 3, it is 3. Now we will do for the second row. So second row into column. So 0 into 1, it is 0, minus j into 1, it is minus j, minus 1 into 2, it is minus 2, j into 3, it is plus 3j. Okay, so we'll go for the third row. So third row, same column, this is the same column. So 1 into 0, it is 0, minus 1 into 1, it is minus 1, again 1 into 2, it is plus 2, minus 1 into 3, so this becomes minus 3. So again 0 into 1, it is 0, 1 into j, plus j. Okay, so minus 1 into 2, so this becomes minus 2. Again, last value minus j into 3, so this becomes minus 3j. See here, 0 plus 1 plus 2 plus 3, it is 6. Okay, again you have minus 2 and plus 3j and minus j, so this becomes minus 2 plus 2j. Okay, so the next value is minus 3 and minus 1, so this becomes minus 4. Minus 4 plus 2 means, so this becomes minus 2, and the last value you have minus 2j. Okay, so this is 2. So these are the values we have got. So you have to write this value. For writing this line also you have 1 marks. So x of k is equal to, open the bracket, 6 comma minus 2 plus 2j. Okay, minus 2 minus 2j. So these are the DFT values for the sequence x of n. We have started with x of n 0, 1, 2, 3. So this is in time domain. So these values are in time domain. So when I convert from time domain to frequency domain, so you are going to get this value. So what are the values? So this is x of 0. So this is x of 0. So what is this? This is x of 1. So this is x of 2. And these values are x of 3. Okay. So these are the values of x of k, that is nothing but DFT values. We have calculated the DFT value using linear transformation, that is nothing but matrix method. So we'll go for the next problem. So what we will do for the next problem, we will take the same value and we will try to calculate the inverse DFT. Okay, using the same method. Okay, so the second problem, for the given sequence or given value x of k is equal to 6 comma minus 2 plus 2j minus 2 minus 2 minus 2j. Okay, now for this sequence we are going to calculate the IDFT using matrix method. IDFT. Okay, so first is how much is the value of n here. From this I can make out the value of n is how much. It is 4. We have 4 values, so n is equal to 4. So what is the equation for the matrix? So it is, we are calculating IDFT. Okay, so IDFT means it is x of n is equal to 1 by n omega n of priddle factor x of n. Okay, or in some books it has been given as x of n. So they will use this bracket like this. So this will represent the matrix. So is equal to 1 by n omega n kn. So open the bracket, conjugate x of k. So this one you put it into bracket. So this is all, writing of this is also correct. This is also book. In some book they have taken like this. In some book they have taken like this. Okay, both are correct. You can see my video, that is module 1, lecture 5, that is last video. We have done the calculation for what is that, linear transformation, that is matrix method. Okay, so first I will write the matrix for omega n. Now only we have calculated 1, 1, 1, 1, 1 and 1. So this is what, minus j, minus 1 j. Okay, so this is minus 1, 1, minus 1 j, minus 1, and it is minus 1. So for this matrix we have to take the conjugate. Now what is this? This is omega n. Also I can write omega n, that is nothing but omega 4. So now if I take a conjugate of this, so that is nothing but omega 4 of conjugate. So this will be equal to, see, 1, 1, 1, 1, 1. This will be, this we are not changing. Wherever there is an imaginary part, so if it is plus it will become minus, and if it is minus it will become plus. For example, z is equal to a plus jb So this is, we know that this is real and this is imaginary. So if I take a conjugate, so imaginary part will not change. It will be same as it is, but this will become minus j of b when I take a conjugate of this. So z of, if I take a conjugate of this, so this becomes like this. Okay, so you have a j value here, minus j, so this becomes plus j. Minus 1 I'm not going to change, I will going to keep it like that only. So you have a j plus j, so this becomes minus j. Okay, so you have a minus, so this is all the real parts, so this is all are real, 1 1 1. So this is, this I cannot change these values. Can I change these values? I cannot change these values. So wherever there is a j value, so that is, I'm going to change it from plus to minus and minus to plus. So this becomes minus 1 1 minus 1. So you have a plus j here. So this becomes minus j minus 1. You have a minus j here. So this becomes plus j. Okay. So this is the matrix when I take a conjugate for omega 4. Okay. So now we will start doing the calculations. So I'll rewrite the formula. So it is x of n 1 by n omega n of into x of n. This is this one. How do we write? Matrix for x of n. So x of 0, x of 1, x of 2, x of 3. Okay, so this is equal to, what is this? 1 by n means 1 by 4. Just now we have calculated. This is 1 1 1 1 j minus 1 minus j. So this was minus 1 plus 1 minus 1. So this became j minus j minus 1 and plus j. Okay, multiplied with x of k, that is x of 0, x of 1, x of 2, and last value is what? X of 3. Okay, so these values we know that, so what is x of 0? X of 0 is how much it is? 6. Okay, so how much was x of 0? X of 0 is 6. How much is x of 1? X of 1, it is given as minus 2 plus 2j. Okay, so what is x of 2? X of 2 was minus 2, and last value it is minus 2 minus 2j. Okay, so if you want, you can see here what was the question here. So this one is your x of 0, this one is your x of 1, this is your x of 2, this one is your x of 2, this is our x of 3. Okay, so that's these values I have substituted. In place of x of 0 I have substituted 6. In place of x of 1 I have substituted minus 2 plus 2j. In place of x of 3 I have substituted minus 2 minus 2j. Okay, now we will do the calculations. This is equal to 1 by 4. So 1 into 6, 6. Minus 2, 1 into minus 2 plus 2j. Okay, so 1 into minus 2, so this is minus 2. Again 1 into minus 2, again 1 into minus 2j. So this is minus 2j. So this one and this one will get cancelled. Minus 2, minus 2, minus 2, this minus 2, this minus 2, this minus 2, and this 6 will get cancelled. Okay, so this one you are going to get it as 0. I'll write down here 0. Okay, so next is what? So this row and this column has to be multiplied. So this is 1 into 6, 6. Okay, so this is minus 2j. Okay, plus 2j square, minus into minus, so this becomes plus 2. So this one minus 2 into minus 2, so this becomes plus 2j, and this one is minus j into minus 2, so this becomes plus 2j. Okay, so minus into minus again plus, so again it becomes 2j square. Okay, so this one and this one will get cancelled. So what you have here 6 and you have here 2, so this will be 8. Here I'll write the calculations. 8 8. So this is 2 plus 2, 8. And what is left here? 2 plus 2j and plus 2j. So this becomes plus 2 means it becomes 4j square. So this is 8 plus 4. J square is how much? It is minus 1. So this is 8 minus 4. So this is 4. Okay. So this will be 4. Okay. So the next value is 1 into 6. So this is 6. 1 into 6. Okay. So this is 1 into this whole term you have to multiply. So this becomes plus j plus 2 and minus 2j. Okay, so you have next value 1 into minus 2. So this becomes minus 2. Okay, so the last value in this row is minus 1 into this whole term, So this becomes plus 2 and plus 2j. Okay, so if you see this 2 and this 2 will get cancelled. So how much you are going to get here? 6 plus 2, so this becomes 8. 8, and this 2j and this 2j also will get cancelled. So this value is 8. Okay, now we will go for the last row. 1 into 6, it is 6. Okay, minus j into minus 2, so this becomes plus 2j. Okay, so minus j into plus 2j, so this becomes minus 2j square. Okay, so minus 2, this one, minus 2, this one. So minus 1 into minus 2, so this becomes plus 2. Last value is what? So can you see this? This is plus j and this whole term you have to multiply. So this becomes minus 2j. Okay, so again minus 2j square. Okay, so this and this will get cancelled. So what you have? 6 plus 2. So this is 8 here. 8 and minus 2j square, and you have a minus 2j square. So this becomes 4j square. So this will be equal to 8 4 into minus 1, because j square is how much? J square is minus 1. So minus 1. So this becomes 8 plus 4. So this will be equal to 12. So this value is, so this is equal to 1 by 4. Okay. So next is what? If I divide this, so what I'm going to get? 0. 4 divided by 1 by 4, so this becomes 1. 8 divided by 1 by 4, so this becomes how much? 2. Again 12 divided by 4, so this becomes 3. So these are the values. So we will write down the values for x of n. So x of n, how much we have got? We have got as 0, 1, 2, 3. Okay, so we started the first problem. We have taken the same sequence and we have calculated the DFT. We got these values, and for this same value we have taken IDFT. So what we have got, once we take the IDFT, we have to get the same values what we have started. So we are getting the same value. Okay, now we will do problem number 3. For a given sequence x of n is equal to 1, 2, 2, 1. Find x of k or compute DFT using matrix method. The given values here are x of n is equal to 1, 2, 2, 1. Okay, so we'll write the formula for this. It is x of n is equal to omega n x of n. Okay, so this matrix x of n is a matrix of size n into 1. So what is n here? What is the size of the n from here? See, in the problem they have not given the value of capital N. So from these values, that is x of n, from these values I can make out, we can calculate that n is equal to 4. Okay, so this matrix will be 4 cross 1. So the values are x of 0, x of 1. These values we have to calculate, x of 2 and x of 3. is equal to matrix omega n is the matrix of 4 cross 4. So that is omega n kn. So what is k? K is also, the range of k is what? 0 to n minus 1, and the range of small n is also, it's a range from 0 to n minus 1. Okay, so both ranges n minus 1, so n is equal to 4, that means it is 0 to 3. So k are rows, k values are rows, we are representing as rows, and n values are columns. Okay, so this will be, we have calculated, I will tell you the easiest method to write down this matrix. So just write here 1 1 1 1 1 1 and 1 1 1 and 1. See here, this side diagonal, it is plus j, it is minus j here, diagonal. Can you see here diagonal? It is minus j, and here also it is minus j. So here it is plus j diagonal, and this is plus j, and all the values here. So this 1 minus 1, here also minus 1, here also minus 1, and here also minus 1, and the middle value is plus. So this is easiest way to remember the matrix. Okay, so here, so this one we will get when k is equal to 0, k is equal to 1, k is equal to 2, and k is equal to 3. And here this side we get the values when n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. So this will represent the columns, and this k will represent the rows. Okay, so this calculations we have seen while doing the problem number 1 in the same video. Okay, so now I will write the matrix for x of n. So this one is x of n. Okay, so this is again 4 cross 1 matrix. So this is x of 0, x of 1, okay, so x of 2 and x of 3. Okay, now we will substitute the value of x of 0, x of 1, x of 2, and x of 3. Okay, so the value I'm going to substitute here. So in place of x of 0, I'm substituting 1, and in place of x of 1, I'm going to substitute 2. In place of x of 2, I'm going to substitute 2. In place of x of 3, I'm going to substitute 1. So these are the values of x of n. X of 0, this is x of 0, this is x of 1, this is x of 2, and this is x of 3. Now we'll start doing the calculations. So it is, you have to multiply rows into columns. Okay, so the 1 into 1, it is 1, 1 into 2, it is 2, 1 into 2, it is 2, again 1 into 1, it is 1. Okay, we'll go for the second row. This is the second row, and we have to use the same column. So it is 1 here, it is 1 into 1, 1, 1 in minus j into 2, it is minus 2j. Okay, again minus 1 into 2, this one, minus 1 into 2, so this becomes minus 2, and last value is minus it is last value is j into 1, it is plus j. Okay, so next value is what? My 1 into 1, 1. Next we have to take this row and the same column, so it is 1 into 1, 1, minus 2, then again 1 into 2, it is 2, minus 1 into 1, minus 1 into 1, it is minus 1. So the last row, that is 1 into 1, it is 1, 2 into j, it is 2j, minus 1 into 2, it is minus 2, minus j into 1, it is minus j. Okay, so how much is this? So this is equal to 2, 1 plus 2 plus 2 plus 2. So it is, how much it is? 6. So here plus 1, you have a plus 1 and minus 1, so this becomes minus 1, and you have minus j, 2 minus j and plus j, so this becomes minus j. So the next value is what? plus 2 and minus 2 will get cancelled, and plus 1 and minus 1 will get cancelled. So the third value is 0, and this one is plus. Okay, so here you have minus 2 and plus 1, so this becomes minus 1, and you have plus 2j and j, so this becomes plus j. Okay, so these are the values here. These are the values here. We'll rewrite this values. So that is x of k is equal to, it is what we have got. We have got 6 minus 1 minus j 0, and we have got it as minus 1 plus j. Okay, now we will go for the next problem, that is fourth problem. What we will do, we will take the same sequence and we will calculate IDFT of it. Okay, so the problem number 4, we will take the same sequence, and we will calculate the IDFT using matrix method. Okay, so first one we will write the equation for that. It is x of as it is IDFT, it is x of n is equal to 1 by n. Okay, so total n conjugate of x of n. Okay, so this is the equation for IDFT. We will write the matrix first for this. I have shown you the matrix. What is the n value again here? The n value is 4 here, so it is 1 by 4. 1 by 4. Twiddle factor, I have given the matrix of twiddle factor. See, I have shown you the twiddle factor, how to take the twiddle factor conjugate in problem number 2. You can refer the same problem. I'll write the matrix here. It is 1, 1, 1 and 1. These values will be same, 1, 1 and 1. So this is plus j, and this side is your plus j. Okay, so this is minus j. Only j values will be reversed, minus j. So this is minus 1, minus 1, minus 1, minus 1, and this is plus. Okay, so this is conjugate. So this matrix is omega 4 of conjugate, or I can write it as omega n of conjugate. Okay, so I will substitute directly these values here. So this next we have to multiply it with x of k matrix, this matrix. So what are these values? So these values are given as 6 minus 1 minus j, minus 1 minus j, 0, and the last value is minus 1 and plus j. Okay, so we will do the calculations now. It is 1 by 4. So it is 1 by 4. So see this row and this column you have to multiply. So 1 into 6, it is 6. 1 into this value, whole value, you have to multiply. So this becomes minus 1 minus j. So the next value is 0. So plus 0 directly I'm going to write. So this value is this into this whole term. So this becomes minus 1 plus j. Okay, we'll go for the second row. So this is the second row and the same column. Okay, so this becomes 6. Okay, this value into this value, so this becomes minus j. Okay, so minus j square, Okay, so next value is what? 0. So I'll directly write it as plus 0, and the last this value is minus j, has to be multiplied with this. So this becomes minus into minus plus j. Okay, so minus j square. Okay, so the next value, so this is your row, third row, and the column. So it is 1 into 6, 6, minus 1 into minus 1 plus 1, minus 1 into minus j, so this becomes plus j. So the next value is 0, and this value has to be multiplied with this value. Okay, so this becomes minus into minus, so this becomes plus 1, and this becomes minus j. Okay, so the last row, so this is the last row and the same column. So this becomes 6. Okay, 6. Okay, so this becomes plus j minus j square plus 0. Last value is minus j plus j square. Okay, so these are the values we have got. Okay, so we will rewrite the values here. So what is this? This is 1 by 4. If you see this minus j and this plus j will get cancelled. Okay, what you have here, you have 6 and minus 1 you have, so this becomes 6 minus 2, so this becomes 4. So the first value is what I'm going to get is 4. Okay, so the second value is what, see here, so this j and this j will get cancelled. So you have 6 plus what you have here, 6 you have, then you have minus 2j square, correct? So 6 minus 2, j square is minus 1, so this becomes 6 minus into minus plus 2, so this becomes 8. So the second value is how much? It is 8. So we'll go for the third value. So this cancels and this plus j and this minus j will get cancelled. So this 6 plus 1 plus 1, so this becomes 8 here. So this is 8. Okay, so this is plus. Okay, minus j and plus j will get cancelled, plus j and minus j will get cancelled. So what we'll get, 6 plus 2j square, 2j square here, you have 2j square here, so this becomes 6 plus 2, what is j square? J square is minus 1, so it is 6 minus 2, you are going to get 4 here. So what you are going to get here, this is 4, this one is 4. Okay, so 4 divided by 4 it is 1, 8 divided by 2, 8 divided by 4 it is 2, again 8 divided by this one I'm doing 8 divided by 4 again here, so it is how much? It is 2, again 4 divided by 4, how much? It is 1. So these are the values. So what values we have got it here is x of n is equal to 1 comma 2 comma 2 comma 1. So we have started with this. We have taken a DFT, that is nothing but matrix method is again is DFT only, and we have got it x of n, x of k. Again we have, what we have done, we have done the inverse transform. We have taken the inverse DFT, that is IDFT, and we have got the same values. Okay, so if you want you can write down like this, inverse. Okay, so we have got the same values. Thank you for watching this video. Please subscribe, share and comment, and also comment in the message in the comment box that do you need the matrix calculation for 6 points and 8 points also. Okay, thank you.